Hey everyone, thanks for tuning into this talk. I'm really excited to share SQLRecon with you today. My name is Sanjeev Kawa, and I'm a Red Team operator on the IBM X-Force Red Adversary Services team. I have about 10 years of offensive security consulting experience, and I'm super fortunate to get to work with some of the largest companies in the world who hire our team to compromise their critical business functions. My primary goals are to evade defensive implementations, exercise the blue team, and emulate adversary TTPs to reach target objectives. Here's a quick look at our agenda today. So we're all on the same page, I'll spend the first couple of minutes going over what Microsoft SQL Server is, along with some of the common issues. I'll then introduce a tool I wrote called SQLRecon, which is a C# toolkit designed for offensive-focused reconnaissance and post-exploitation. After that, I'll spend a majority of today's talk performing a live demo of SQLRecon in a simulation of an enterprise network. You're definitely going to want to stick around for all the demos, but if you're watching a recording of this at a later date, things start to get pretty spicy around demo number 8. I'll then wrap it up with some defensive considerations. Let's jump straight in. So for those of you who are unfamiliar with SQL Server, the long and short is it's a relational database that allows the storage and the retrieval of data by users, web applications, desktop applications, and really any other form of business intelligence. Deployments can vary between SQL Server being installed on top of Windows Server on-premise, and this implementation also extends into the cloud, but it's also deployed serverless in the cloud as well. In my experience, most industry verticals rely on enterprise Windows networks. As I navigate my way through these large and often complex enterprise networks, it's quite common to discover SQL servers which have been typically deployed to support a business function. Now, one of the things to think about as we continue is that SQL Server isn't just used for data storage and retrieval. Because of its tight integration with Active Directory, it can facilitate with unrealized unauthorized access, lateral movement, command execution, and privilege escalation. One of the most common misconfigurations I continue to see in enterprise networks is the ability for low privilege groups or authenticated domain objects to connect to SQL servers. This only requires a valid domain context, and it usually provides limited access to SQL Server. This means that if the workstation of a regular business user is compromised and a network route exists to a misconfigured SQL Server, it's actually possible for an adversary to conduct some of these attacks which are listed on the slide here. These issues with SQL Server are still being abused to this day. Kaspersky published a great article in late 2022 reporting a significant uptick in SQL Server attacks by some of the adversary groups that they observe. Now that we have our bearings with what SQL Server is and what the attack surface can look like, let's introduce SQLRecon. There have been several tools developed over the years to attack SQL Server, and these are just some of the more popular ones up on screen here. The one that I always ended up reaching for when I was a penetration tester was a tool developed by Scott Sutherland over at NetSPI called PowerUp SQL. But as a Red Team operator, I often interact with systems that I've compromised in our client networks using command and control frameworks, or C2. And the clients that I work with usually have mature cybersecurity programs, capable defensive teams, and modern security controls, such as EDR solutions, endpoint detection and response solutions. Now, EDR solutions can be a formidable opponent to go up against, as they do a really good job detecting malicious open source tooling designed for offensive security, especially those that rely on PowerShell, or Ruby, or Python. And using something like that on the engagement that I was on would have been a surefire way of getting caught by the defensive team. So the idea behind SQLRecon was to address this post-exploitation tooling gap by modernizing the approach Red Team operators can take when attacking SQL servers. The tool is super modular, it can be extended really easily, and it's compatible standalone or within a diverse set of C2 frameworks. When using the latter, SQLRecon can be executed in process or through traditional fork and run, and I kind of designed it not to be just used by Red Teamers, but by Blue Teamers as well, or by developers, or really anyone who doesn't have a lot of experience with SQL databases and just needs to interact with one. Now, SQLRecon is a public tool, but today I'm going to be releasing a version that is privately used by the IBM X-Force Red Adversary Services team on real-world engagements. In the public release, SQLRecon had 3 ways that you could connect to SQL Server, and the new release adds 2 additional authentication providers, which we'll talk about a little bit later on. The public release of SQLRecon had a diverse range of enumeration and exploitation modules, about 57 of them. But in the new release, that module count has been bumped up to 83, and SQLRecon's also had a complete rewrite and supports attacks against SCCM databases now. Additionally, there's been enhancements to the overall operational security for Red Teamers through things like continuous authentication, validation, and execution guardrails. Now, SQLRecon is really straightforward to use. First, you just need to set an authentication type, then a host that you're targeting, and then finally one of the 83 modules. There are some optional arguments that allow you to specify like what database you want to connect to, as well as what port you want to connect to on the remote server. And by default, these are set to master and 1433 respectively. So the example on screen here just shows you how you would enumerate databases on a SQL server. And of course, shorthand arguments are also supported throughout if you don't want to type, auth, host, and module. Let's talk about some of the ways that SQLRecon can connect to a SQL database. The first is just using the current user's token, whether it's a domain user or a computer account. And next, we have a new provider called WinDomain, which actually allows you to specify domain credentials. Of course, if you've found some credentials in a file somewhere and it's just a local set of database credentials, you can use those too to connect to SQLRecon. And this is if the server may not even support Windows authentication. And SQLRecon also supports connecting to databases hosted in the Azure cloud using Active Directory or Azure Active Directory credentials. Lastly, another new provider is that you can also connect to Azure databases using local database credentials too. Now, I don't really want to speak about all of the 83 modules because let's face it, we all want to just jump straight into the demos, but this table kind of just provides you an overview of the modules that facilitate with privilege escalation, lateral movement, and command execution. I'll leave this up for 5 seconds or so, just let your eyes wander. All right, it's demo time. So in this demo, and to be fair, in the majority of the following demos, I'm going to be operating from a compromised Windows 10 workstation located in the Kawa Labs domain in context of the Jeff Smith domain user account. I thought we'd just start by evaluating this user's permissions just to make sure they're not anything crazy like a domain administrator, and they truly are just an unauthenticated user in the Kawa Labs domain. All right, a short and sweet demo to see what our user's permissions are in the domain. And as we can see, J Smith is just a regular domain user. Next, let's talk about how we can find Microsoft SQL servers in an enterprise network. Using server principal names is a super effective way to quickly find SQL databases in a domain. Now keep in mind, this isn't going to find all SQL servers, but it's going to have ones that have a registered SPN. Shout out to Daniel Duggan, who's Rasta Mouse on Twitter, for adding this capability into SQLRecon. Enumeration modules always go into the /e flag or the enum flag, and you can also specify a domain name if you want to. It's optional in case you want to enumerate SPNs from another domain, but you can also chop it off and it'll use your current primary domain that you're in. Here we can see that there's been several MS SQL SPNs that have been discovered. One for an SCCM server and another for SQL02. One of the things that I like to do once I found a SQL server is pull some of its information and metadata. Shout out to Rastamouse once again for introducing this capability into SQLRecon. So in order to gather some information from SQL01, I'm just going to be using JSmith's Windows token to authenticate against it. And here we're going to see we get back some pretty useful information. We get to see that it's running Server 2022, it's running SQL Server Express Edition, version 16, and it supports both modes of authentication. In addition, MS SQL SVC Service account appears to be running the SQL service. In this next demo, I'm going to be leveraging a hybrid Active Directory implementation where AD Connect has been used to tie the on-premise domain with the Azure cloud. This is a pretty common implementation for most enterprise networks. And so in this configuration, I'm going to use Jeff Smith's standard domain credentials to connect to a misconfigured e-commerce SQL database in the Azure cloud and determine what permissions the user has on this e-commerce database. All right, so here we can see we're using the Azure AD authentication provider to connect to the e-commerce database living in the Azure cloud, and we're issuing the Who Am I module against it. This will enumerate all the different roles on the database and return whichever roles the user is a member of. So now that we know we can connect to the e-commerce SQL database, let's see what we can find inside of it. So we're going to be connecting right back up to our e-commerce instance in the Azure cloud. But this time we're actually going to be using the databases module, and this will help determine what databases are on this remote SQL Server instance. Here we see there's two, master and payments. Master is going to be part of most SQL servers, and then payments definitely looks like a custom database. So we can actually issue an ad hoc SQL query with SQLRecon to grab basically everything that's inside of this CC table on the payments database. So let's take a look at what could be in there. And here's an example of just receiving a bunch of data from the database using a custom query command. Some people might be wondering how I knew what the table name was when I issued that custom ad hoc SQL query. Well, there's actually a tables module which can help you list all the tables in a database. There's also some other useful modules that can help you list columns, get a count of rows before you decide to dump like the contents of a super large table, and also search for keywords. Now that we got some of the basics down, let's start ramping things up by getting into some attacks. The first one we have here is a pretty well-known and simple technique where domain users can perform a UNC path injection attack to solicit an authentication request from a SQL server to get hashed credentials. In this demo, we're going to connect to SQL02 in context of Jeff Smith, and we're going to initiate an SMB connection to a host that's in our control. This host is on the top part of our screen, and I'm going to start an SMB server audit. Now I'm going to go back into Cobalt Strike, and I'm going to get SQL02 to send an authentication request to the SMB server. Because it needs to connect to the SMB server, what we're going to see is that it needs to send its net and TLMv2 credentials across, and we're capturing those. So we can use these credentials in a variety of different ways. We can try to crack them, or we can relay them off to a separate host. I think one of the best things about SQLRecon is that it was built with operational security in mind, specifically with continuous authentication and execution guardrails. This is super critical for red teamers because we don't want to unintentionally perform actions that get us detected. So in this next demo, we'll look at what this means. Alright, so let's use our low privilege user account to connect to SQL01 and leverage XP command shell to issue the task list command. So typically XP command shell is going to be disabled by default, and so SQLRecon has an enable XP module where you can enable XP command shell before you decide that you want to run commands. However, because of the execution guardrails in place, this user's privileges don't meet the necessary requirements to enable XP command shell or execute commands, and so we get a permissions error, as opposed to SQLRecon just sending commands to the SQL server without regard for permission context. Before I move into the next demo, I thought it'd be best to give everyone a quick description of what SQL impersonation is. This is a special permission that enables a user or a group to operate with the permissions of another user along with their own permissions. The following screenshot here is taken from a backend configuration of a SQL server called SQL02 and demonstrates that the built-in user's account can impersonate the SA account, or the local administrator account of the database. I've seen pretty similar configurations to this in real-world environments where specific Active Directory groups are tied to high-privilege local SQL accounts. Alright, so with that out of the way, let's abuse impersonation in context of the low-privilege Jeff user on SQL02. Okay, so using the low-privilege JSmith user account, we're going to connect to SQL02 and enumerate all users that can be impersonated. Here we can see that the SA local SQL account can be impersonated. This is really useful because it allows us to act in the context of a system administrator on the underlying SQL database, and it will allow us to break through the confines of SQL to execute commands on the underlying operating system. All of the impersonation modules in SQLRecon are prepended with the I character, and you will also need to specify the user that you want to impersonate. So with this command, we're going to be enabling OLE automation procedures, which will allow us to execute commands on the underlying system. And there we see we're able to impersonate the SA user account to enable OLE automation procedures. Next, I'm actually going to be leveraging PowerShell to download a payload from an internet host and then execute that payload. This isn't something I'd normally do on a red team engagement, but I just thought it'd be really easy to demonstrate just doing something like this, and this will allow us to actually laterally move to SQL02. So let's go ahead and download and execute our payload using OLE automation procedures. And as we can see, we've laterally moved to SQL02. Something to keep in mind from an OPSEC perspective is that SQLRecon will always create randomly generated names when you're creating methods, and it'll also destroy those objects that it creates as well. Okay, I'm just going to clear the console window just so we have a blank canvas to work with moving forward. And let's use impersonation to go ahead and enable XP command shell. So again, we're just connecting to SQL02 in context of the JSmith user account, and we're using the SA account to enable XP command shell. And we can see it's been successfully enabled. So let's execute the tasklist command, which will start the tasklist binary on the underlying operating system to get an idea of what processes are running. There we go. We can see a bunch of different processes running on SQL02. Now, we want to revert this environment back to its original state. Now, so for those reasons, we have modules such as disable OLE built in, as well as disable XP built in as well. So we can revert those changes that we made to the underlying SQL Server database where we enabled those two modules, and now we can go ahead and disable those. SQLRecon can also perform attacks against linked SQL Server instances. The implementation of linked SQL servers is pretty common as they usually offer redundancy or the ability for one SQL server to interact with a database of another SQL server. This screenshot is taken from the backend configuration of SQL02 and demonstrates that SQL02 has a link to SQL03. Configuring a link from one SQL server to another often requires a set of privileged credentials to establish and bind that link. This is really beneficial for red teamers and adversaries as it allows commands to be executed on that linked SQL server in the context of the account which established and bound that connection. Another point of consideration is that linked SQL servers may be segmented from your immediate network that you're on, and this could present the opportunity to traverse segmentation boundaries and enter a network zone of higher security requirements. In this demo, I'm going to demonstrate laterally moving from the compromised workstation to SQL03 via abusing a link on SQL02. To do this, I'll take advantage of something called CLR integration, which is a pretty crazy feature in SQL Server. CLR integration allows custom .NET assemblies to be imported into SQL Server. And these assemblies are stored inside of a stored procedure before they get executed, which makes for a really nice lateral movement attack primitive. The code snippet here just demonstrates a very simple example of a custom SQL assembly. You can find more samples at my just below or at the SQLRecon wiki. You basically just need to import some references, set a very specific class name to get a SQL CLR compatible .NET assembly. All right, let's jump into it. Okay, so let's go ahead and connect to SQL02 in context of a low-privileged JSmith user account and enumerate whatever links might be on that server. And as we can see, SQL02 does indeed have a link to SQL03. Now, every single linked module in SQLRecon will be prepended with the L character, and you will also need to specify the linked server that you want to connect to. So with this L who am I module, we're going to be determining what rights the JSmith user account has on SQL03. And keep in mind, this is actually going to be leveraging the connection which binds the link between SQL02 to SQL03. So we're actually going to be inheriting those permissions. And as we can see, we are a member of the sysadmin role, and that's because we are actually using the account which binds the connection between SQL02 to SQL03. So let's go ahead and use the linked enable CLR module to enable command line integration, which is typically disabled by default. Now that CLR integration has been enabled, let's instruct SQL03 to make a connection to a remote web server and download a DLL which we have disguised as an image file. At that point, it will load the DLL into a stored procedure and execute a function called execute shellcode. Now, SQLRecon does also support DLLs being loaded from remote file shares and from disk as well. You don't necessarily have to download the .NET assembly from a remote web server. And there you have it. We can see that we've laterally moved to SQL03 in context of the MS SQL SVC service account. As noted before, any object that's created inside of the database will always be generated with a random name, and they will always be deleted afterwards. A couple of months ago, TarLogic came up with a proof of concept of using ADSI links, or Active Directory Service Interface links, to get clear text domain credentials. So ADSI links allow SQL Server to query Active Directory for domain objects like users, groups, and computers. This screenshot is taken from the backend configuration of SQL03 and demonstrates that SQL03 has an ADSI link to the primary domain controller in the cowlabs.local domain, which is DC01. Configuring an ADSI link from an instance of SQL to Active Directory doesn't necessarily need privileged credentials. However, during real-world operations, I've seen cases where the principle of least privilege just hasn't been applied. In this demo, I'm going to demonstrate how we can abuse a double link scenario to obtain clear text ADSI credentials. Let's go ahead and connect to SQL02 in context of our low-privileged JSmith user account and enumerate the links on SQL03. As we can see, SQL03 has an ADSI link to DC01. What we can do at this point is we can instruct SQL03 to load a custom .NET assembly that has a local LDAP server on it. We're going to get the LDAP server to listen on port 49103. At this point, the ADSI authentication will be temporarily redirected to this local LDAP server on SQL03, and we can receive the clear text credentials for the account that binds the ADSI link from SQL03 to DC01. And of course, we clean up everything afterwards. There we have it. Here is the clear text ADSI link credentials from SQL03 to DC01. One of the biggest extensions to SQLRecon comes from one of my colleagues, Dave Casa, who is Golden Gunsec on Twitter. He introduced a bunch of modules that can be leveraged to abuse Microsoft System Center Configuration Manager or Microsoft Endpoint Configuration Manager's databases. All of these modules were developed off the back of a real-world engagement, and to be fair, in most cases, interacting with SCCM databases does require an elevated privilege context, or access to the SCCM server needs to be obtained. That's not to say that there aren't actual misconfigurations in the wild, though. So let's perform some really basic SCCM collection through the SCCM database. Okay, so I've got a Cobalt Strike beacon running on my Microsoft Endpoint Configuration Manager server in context of the MS SCCM service account. And what I've just done is I've connected locally and enumerated the databases which are on this SCCM server. The one that we're looking for is cm_kaw, as that's going to contain the configurations for all of the SCCM application. So let's go ahead and take a look at the users that have been configured in SCCM. You'll notice that all SCCM modules are prepended with the S character, and you do need to specify the database that you want to connect to. So I did specify the cmkaw database. So these users, and actually one group as well, the SCCM support group, have been configured to access the SCCM application and perform some level of management. We can see the permissions and the different sort of roles that they've acquired. So using the task list command, we can see what tasks have been configured inside of SCCM, and it's just a couple of different installation package management style tasks. This will be the last demo for today, and I'll demonstrate how we can obtain clear text credentials from an SCCM database. So SCCM will usually need to vault encrypted credentials, which are used to authenticate to systems or resources in an environment to do things like deploy software packages or any of the other various things that SCCM does. Let's see how we can abuse this. Okay, so SCCM does need to vault credentials to connect to various different resources in the network. And these credentials are encrypted. So the scredentials command will just basically list the different credentials which have been vaulted by SCCM. At this point, you can make the decision as to whether you want to decrypt those or not. And shout out to Adam Chester, who's XPN on Twitter, as he wrote this kind of decryption routine. And you will need to be running in context of a local administrator account or on the SCCM server itself in order to go ahead and decrypt those credentials. And there you have it. Let's move into some defensive considerations. The SQLRecon wiki page has over 20 recommendations to prevent, detect, or mitigate SQL Server attacks in your network. Please do check this out because we've all just seen what the depth of compromise is when it comes to misconfigured SQL servers. I really wish we had time to go over all 20 of them, but I thought I'd pick the top 3 in each broad category. Here are my top 3 recommendations when it comes to network security controls. So you really want to make sure that you understand what subnets or zones in your network can connect to SQL servers and limit those as much as possible. It's really quite rare that a workstation level network needs to interact with networks that contain SQL servers. In addition to that, if you have network logging and monitoring in place, make sure that you are receiving telemetry for SQL connections and maybe even queries which fly across different network boundaries. There are also a lot of things that can be done to protect the endpoint, but I think the top 3 to focus on involve making sure that you regularly test your EDR or endpoint controls to make sure they detect things or prevent things like unsigned binaries from running, and that they can scan memory for .NET assemblies. Also, some EDRs are capable of providing network telemetry, and this can be a great analysis source to determine anomalous SQL Server network connections from compromised endpoints in a network. Lastly, there's really no shortage of SQL Server security controls that can be implemented. I found that following the Microsoft SQL Server Best Practices Guide eliminates 80 to 90% of these attacks. Minimally, just really make sure that you're not allowing low privilege groups to authenticate against SQL Server. This actually might soon be an out-of-the-box feature as configurations like this have started to make their way into Azure. Also, please do make sure that you take the time to evaluate your SQL servers for things like impersonation accounts, evaluate your link SQL binds, as these can help prevent privilege escalation attacks if the principle of least privilege is applied. Thanks so much. Please reach out to me if you have any questions.